In the last example, I showed how to initialize an array, that is, how to put items into each slot of an array using square bracket notation. I put an index number between square brackets after the array variable name, and then I just assigned whatever value I wanted to be stored at that position in the array, as you can see in this example here. Now, you can also initialize an array at the time it's declared. To do that, you have to assign a comma-delimited list of items enclosed by curly brackets. Now, I've got an example here. Let me open from the source code archive for step 6. This is the project 01_arrays. Now, here you can see that I declare and initialize an array that contains 5 integers. In fact, when you initialize an array in this way, you don't even need to specify the number of items between square brackets. The C compiler automatically creates an array capable of holding the specified number of items. Now, bear in mind that's only when I initialize the array at the time I declare it. So here I can delete this part, this 5, and the code will work just the same. And here are some other arrays that contain 4 doubles and 6 chars respectively. The 6th char here being a null string terminator. That's /0 for null. Now, since character arrays are so common in C because they're used to define strings, that's bits of text such as hello world, there is an alternative shorthand way of assigning a string to an array of chars, and you can see an example here. Now, when a string is assigned in this way, the null terminator, that's the char /0, is appended automatically. So you don't need to add it explicitly, as you do if you assign chars one at a time, as I did in this previous example here. Once you've created an array that contains a list of items, you're very likely going to want to process those items in some way at some time. To do that, you'll need to count through or iterate over all the array items. The for loop gives us one convenient way of doing exactly that. Now here, this loop iterates through the 5-element array int array, counting from 0 to 4, that is, starting with I at a value of 0 and continuing while I is less than 5, and of course the for loop increments the value of I, adds 1 to the value of I at each turn through the loop. The code places the value I plus 1 multiplied by 100 into each successive slot of the array. Since I starts with the value 0, I plus 1 starts by giving the value 1. So the value placed at index 0 of the array is 100. Let me just run it to show this working. So this is the result of running this for loop. As you can see, the values at each successive position in the array are 100, 200, 300, 400, 500. Now, you'll notice here that I've put parentheses around I plus 1. That's to show that I want the result of that calculation to be multiplied by 100. Let's see what happens if I omit these parentheses and run it again. And let's see again the results up here. And you can see they're different. Instead of displaying 100, 200, 300, and so on, it shows 100, 101, 102, etc. In other words, this calculation is now done as 1 times 100, and then the value of I is added to that. In C, as in other programming languages, mathematical operators have what's called differing precedence. Precedence dictates the order in which expressions are evaluated. Operators with a higher precedence cause evaluation before operators with a lower precedence. And it turns out that multiplication and division operators have a higher precedence than the addition and subtraction operators. And so multiplication in an expression like this will be done before the addition. Well, I don't want that, so I need to force the results that I want. And what I want to happen is that I is added to 1. This is now one whole expression which is evaluated as a single entity, and the result of that addition is then multiplied by 100, all just by putting a pair of parentheses around that expression. And in fact, I use parentheses quite a lot in my code, not only to force the order of evaluation, but sometimes it just makes it clearer what my intention is. So it's obvious when you look at this that it's my intention to add I to 1 and then multiply the result by 100. And I can check that this does what I want, and indeed I'm back to the results that I intended to have in the first place: 100, 200, 300, 400, 500.